Hello everyone, welcome to my channel Matthusiasm. This video is day 28 of the 30-day challenge. It is all about integration by parts. Let's check it out. Integrate x times log bracket 1 minus x over 1 plus x dx, where x is between 1 and negative 1. Therefore, 1 minus x and 1 plus x are both larger than 0. This ensures that the term in the bracket is positive, so the log term is real. Moreover, there is another important reason I will show you near the end of this video. Let's call this integral I. We have to decide which term should be absorbed into the differential. Because x is algebraic function a, while this stuff is logarithmic function L. By the Layard's rule, L is in front of a. So L is u and a is dv. In other words, we'll have to absorb x, that is to integrate it. Therefore, the integral is equal to 1 over 2 times integrate log bracket 1 minus x over 1 plus x d bracket x squared. Comparing with the formula of integration by parts, u is the log term, while v is equal to x squared. The first term is a product x squared times log bracket 1 minus x over 1 plus x. The second term is the integral by swapping u and v, which is equal to integrate x squared d bracket the log term. Let's focus on the differential. We have to differentiate log bracket 1 minus x over 1 plus x. To make it simple, let's use property of logarithms to separate it into log a minus log b. Then each of them is easy to handle. Here we apply the chain rule. Differentiating the first one gives 1 over 1 minus x times bracket negative 1. For the second one, it is simply negative 1 over 1 plus x. So both terms are negative. Now we combine the two fractions like this. In the numerator, the x terms can be cancelled out. Also, the denominator is difference of two squares. So it is equal to negative 2 over 1 minus x squared. Here we extract these two parts and write it as a single equation. Dividing both sides by 2, then we get 1 over 2 times bracket negative 1 over 1 minus x minus 1 over 1 plus x is equal to negative 1 over 1 minus x squared. It looks like partial fractions. This result will be used in later part. Come back to the differential. We have the bracket log 1 minus x over 1 plus x is equal to negative 2 over 1 minus x squared dx. Let's put this result into the integral like this. Expand the bracket, then this factor 2 and 1/2 are cancelled out like this. Therefore, the integral is equal to negative x squared over 1 minus x squared dx. Now, we call this integral I1. Let's see how to evaluate it. As the denominator is 1 minus x squared, we add 1 and subtract another 1 in the numerator. Then we can separate the integrand into two parts, 1 minus 1 over 1 minus x squared. The first one is easy, it is simply x. For the second one, we use the results of partial fractions in the previous steps. Then we can evaluate it one by one. For 1 over 1 minus x, we put this negative sign into the differential to change it to the bracket 1 minus x. Likewise, for the second integral, we change another differential to the bracket 1 plus x. In both cases, we can add the constant 1 inside the bracket. Why? Because differentiating a constant is 0. It does not affect the differential. So both integrals are in the form integrate 1 over u du, which is equal to log absolute u plus c. However, it is not necessary to add the absolute signs. We mentioned the reasons at the beginning of the video. It is because 1 minus x and 1 plus x are both larger than 0. Therefore, we get log bracket 1 minus x minus log bracket 1 plus x. Using property of logarithms again, then I1 is equal to x plus 1 over 2 times log bracket 1 minus x over 1 plus x plus constant c. Now we can put the result of I1 into the original integral I. You can see that the two log terms can be combined together. Therefore, the answer is equal to 1 over 2 times bracket x squared minus 1 times log bracket 1 minus x over 1 plus x minus x plus c. It's getting more and more exciting towards the end of this series. Go check out the next integral on day 29. The link is on the screen. I will see you there.